with me, Guy Royce.
Ah!
Hello, Internet peoples. My name is Guy Royce, and today we're going to use Apollo GraphQL, Node.js, and of course Redis to build a simple microservice that exposes data. That data? Haunted places. So grab yourself a Scooby snack and meet me at the spooky house on top of the hill. All right, so I've got a bare bones application set up here already to, well, expose these services, expose this this spooky data. This is really basic. I've got loader and load code and that kind of stuff all done. I've already loaded all the data into Redis. And so I just want to show you what the data looks like in Redis, and then we can dive straight into the graph glory. So just a quick key start here. We'll show you that I've got about 1,600 or 16,000 entries in here. There are three types of data stored in here. There are states. There's not an example of state here, but if we do an hgetall of a state, we'll say state : OH for Ohio, and we'll see that the state entries are the name of the state and the abbreviation of the state. We also have cities in here, so we can say hgetall city : and then let's go ahead and continue with the Ohio theme. I'm in Columbus, Ohio, so we'll say hgetall city Columbus, Ohio, and we can see that that gets us data about that city. We've got the name of the city, the state the city is in, and the coordinates in longitude, latitude format. And then, of course, the most exciting bit is the haunted place. So if we go to places, or place, and then we've got a bunch of numeric IDs from 1 to 10,000 or so. We'll just pick number 1. And we can see that if we expand this up here a little bit, that we get the place number 1 is got an ID of 1. It's got the city that it's in, Ada, the state that city's in, which is Michigan. The location, this is sort of the title of it, or the oh yes, Ada Cemetery, that's a title. A full description of the haunting, and then again the coordinates of that particular location. So that's the data we got to work with. This is a nice, neat little city-states place sort of data, and so it lends itself nicely to using GraphQL, because we can ask for cities, we ask for states within cities, we can ask for places and the city within those, and the state within the city. So it gives us a very simple graph that we can play with. So let's take a look at our code here. As always, I have my cheater code over here on the side here that I will copy and paste from, so that you don't have to watch me type a whole bunch of stuff. So I'm going to do that as well. Let's go ahead and start by installing some packages. We need to install Apollo server, and we need to install GQL. I think it's GQL. Let me double check that before I get that wrong. It's GraphQL. And save those. And that will add those to our package JSON so we can make use of those libraries. And there we go, all installed. Let's take a look now at our code here. So we've got a simple bare bones bit of code here. It's just bringing in Redis, it's bringing in a config file. We've got a little main function that just opens a new connection to Redis. We need to do a little bit more than that. So first things first, let's bring in Apollo server. And then we need to create an Apollo server. And I'm just going to copy that code over here. There are 3 things that an Apollo server needs to start up. It needs type defs. This is the schema, or all the types that we're defining. In our case, our cities, our states, our places, and actually we're going to define coordinates as well. Behind the type defs, we have resolvers. So we need to define the resolvers that sort of get invoked when the type def is mentioned in our query. And then we need data sources. And these are the things that the resolvers use that tell it how to talk to our underlying data store, which in this case is Redis. And in this particular instance, well, in general, as opposed to data types and resolvers, data sources have a function that will allow Apollo to manage the life cycle of when those data sources are created and destroyed. So we need to return a simple object here that is haunted places. And then we can create a new, I'm just going to copy this over here. New haunted places. That way I don't make any typos, right? No one wants me to watch me make a bunch of typos. And that haunted places data source needs to have a Redis connection passed to it. And then there's our closing curly braces. And then this is all the configuration that Apollo server needs to get up and running. The next thing we have to do is actually get it up and running. And so to get it up and running, it's a matter of calling server.listen, and then passing in, I see angry curlies, which means I missed a curly brace and a pair in there. We call server.listen, passing in the port, which we get from our config object. And then we just log out that, hey, we're up and running with cute little ghost emojis. So now if we run this using npm start, it's going to blow up because typedefs isn't defined, and also resolvers isn't defined, and the haunted places data source isn't defined. So we need to define all these things. And we're going to start by getting the states. It's by far the easiest example. It's the simplest example to give us a sort of tracer bullet end-to-end thing to work with. So let's take a look at our schema first. And so the schema is going to be the typedefs, and I'm just going to go ahead and copy those over from my cheater code. Here we've got our typedefs from a schema.js. We have our resolvers from resolvers.js, and our haunted places data source from hauntedplaces.js. And so none of these files exist, of course. So let's create them. Let's touch the schema.js. There's our schema.js. And then for our schema, we need to, we need to define what that looks like. So we need to import GQL from Apollo server. And then we can export a call to GQL that contains our schema. So this will be our schema right here. And there's two bits of schema that we really need. There's the queries and type query. And so these are the queries that we're going to be able to use as entry points into GraphQL. And we want to do something simple, state. And state is the name of the query. And when we invoke this, you'll get a really clear idea of how this works. And the argument the state's going to take is going to be the state. It's going to be the state abbreviation. And it's going to take, not a state, a string. And the exclamation point means that is required. So this is our query to get a particular state by its state abbreviation. So Python OH, and it spits back data for Ohio. Now, the other thing that's going to do is it's going to return a type, and that return type is going to be state. And now we need to define a return type of state. We need to define that state type. State has two things on it that we care about. It has a name, which is string, and it has an abbreviation, which is also a string. So if we get a state by OH, it's going to return a little object that is OH for the abbreviation and Ohio for the name. We pass in CA, we're going to get California, et cetera, for all 50 states and DC. So we've got a we've got a schema defined now. Let's go ahead and save that off there, and we should see our error, a different error now. We should see it complaining that resolvers.js doesn't exist. So let's create resolvers.js. We go into resolvers.js. We don't have much there yet, but we're going to fix that. We need to export default this big hash, this big object. And this object's going to contain all of our queries and states and all the things that we have in our schema need to have some sort of mapping that allows us to talk to actual code stuff. Not all of it does, but we'll get into that in just a moment. So we're going to do our query here first. That maps directly to query in our schema here, right? And it's going to have a type of state. So another property there, state. And then these take little functions as arguments. We got parent, we got args, we got context, and we've got info. These are the 4 arguments that are passed in. And we actually don't need all of these. The parent is used. I'll show how we can use that when we create the mapper for state and then go and delete it because we won't actually need it. The args contain the arguments we passed in. So if we look at our schema here, this would contain the string named state. The context is where our data source will live, and so we need to get the data source out of that. And info is for other things. We actually don't need info, so I'm going to remove it. And I'll show you how to get the state. So if we copy pasta this code over here, you can see that I am pulling the state out of the args. So this will be OH. And then I'm getting the haunted places from the data sources. So the context has a type of a value of data sources, a property of data sources. And and the haunted places is one of those. We could have all kinds of data sources. We just have one. And I'm using destructuring to pull both of these values out. And then the haunted places data source will have a method called fetch state, and we'll pass in that state ID. So you can see we're not using parent here. We are using args and context. So that's how we can query the state. Now, GraphQL will go through and it'll map this, but when it gets the state, it's going to say, well, I need to map the result of calling fetch state to a state object that GraphQL is going to expose. Now, as it happens for us, those structures line up perfectly. So if I do an hgetall on state, we've got name and abbreviation for our two properties. And Redis and fetch states implementation, which I haven't shown you yet, is going to return a hash with a JavaScript object with a value of name and a value of abbreviation. So we don't actually have to do anything. But if we wanted to do something, just to sort of show how this works, I can show you that we have a state here. And then in state, we can say name, and then we can write a function that knows how to handle the name. So that function, just like the state function up here, would take a parent, would take args, would take a context. We actually don't need the args or the context. We only need the parent in this case, and so I don't need parentheses either. And then that would call a function, and we would say parent dot name. Now, here, these match, so we don't need to do anything. But if, for example, we wanted this name to be maybe the name was coming back as name foo or something silly like that. This would allow us to map name foo to name. And then we could, of course, do the same thing with abbreviation, which I'm not going to type it out because abbreviation, I will type it wrong. So, but we don't actually need this because by default, it'll just map the existing names one-to-one. So this little line of code here on line 12 is the default behavior. So we're just going to get rid of that. There we go. And we're going to focus on creating the fetch state function on haunted places. So let's touch haunted places.js. And I spelled haunted wrong. Nunted. There we go. And haunted places is just a simple class with a constructor. You might remember back in the beginning here in app.js, haunted places took a Redis connection in its constructor. That's so that we always use the same Redis connection because Apollo server is going to manage the creation and destruction of these data sources. And but we only want to use one Redis connection because we really don't need more than one. So we pass that in here. And then we just need to add a function beyond that for async fetch state. That's what I called it, right? Fetch state, yes. And that's going to take the state. And this is a very simple Redis function, this.redis.hgetall state. No, that's wrong. State. So as we showed earlier here in our keys are state : and then state abbreviation. This is the state abbreviation coming in. So this is just using string interpolation to build us that same string. And we actually need to return the value here. And this should be a functioning graph server. Let's see. Let's see if it works. Okay, it didn't blow up. That's always a good sign. Let's go to a browser here. And here is our GraphQL playground. It looks like it's not complaining yet. Let's go ahead and get a state with the state of OH. And from the state, we want the name and we want the abbreviation. There we go. I pulled back Ohio and OH. Let's do another state. Let's do California. Sure, there's plenty of haunted places in California. Excellent. So you can see that this totally works. Do Oklahoma. Once heard a great ghost story about this place in Oklahoma that was haunted, and someone had written on the chalkboard, apparently the ghost, "The cake is a lie," and they were trying to understand the meaning of this in this ghost story, not realizing that it was probably teenagers and it's an internet meme. So anyhow, fun story. Maybe I'll link to that news report in the description below, because it was a really funny story. So that is a really super simple GraphQL thing. Let's do something a little less simple. Let's go to our schema here again, and instead of querying state, let's query city. And city's interesting because it returns a state, and so there's some nesting happening here. So for arguments to find a city, we want to have the string of the city name, which is required. We also need a string of the state name, or the state abbreviation. That's also required, and then that's going to return a city. And then down here we can find a type of city, and it's going to have a name, which is a string, and it's going to have a state, which is a state. And this is where it gets interesting, because we're using one of the types we just defined here. And so in our resolvers then, we can add our city resolver here. City. And it's going to look pretty much the same as this resolver, right? These resolvers are all very similar. It has a city and a state in the arguments. Again, we're not using the parent. We, again, need to get the haunted places data source. And instead of calling fetch state, we'll call fetch city. And pass in city and state. And then we need a comma right there. And in our haunted places, we need a async fetch city. And then city and state. And again, this is going to look very similar as well, right? Because we are just going to do an hgetall on a different key, which would be city and state. So let's take a look at that and see if that works. Let's stop and start the server. And spoiler alert, it doesn't work. But we will go ahead and add a city query here. You can add multiple queries here. It's one of the cool things about GraphQL. And we're going to pick Columbus. Columbus. Yes, I do know how to spell the name of the city that I am from. And OH for Ohio. And we're going to get the name. We're just going to get the name for now. That works. Let's go ahead and get the state. And to get the state, we then need to specify properties on the state, including the name and the abbreviation. And this won't work. So why didn't that work? Well, this has to do with the mapping. I showed you before where we could create a mapping for the state in the resolver that would take the name and the abbreviation and map it over, but the default handler did that. In our case, our call to Redis is returning a string with the state abbreviation, but we want a state type. And the state type needs an object, a JavaScript object, that has the name and abbreviation in it. And so we need to do something to map that. And that mapping will happen in the city. And we can say, for the state property of city, async. We'll just copy this bit of code here. We need to get the state abbreviation. And the state abbreviation isn't in args this time, it's in parent. So the parent contains that previous object, that the value that is in the state field for city when the city is resolving. And so here we can pull the state out of the parent. We can get our haunted places data source again, and we can fetch the state and return that instead. And now if we stop and start the server, it should work gloriously well. And there we go. We see that Columbus is the capital of Ohio. Cool. Okay, so that worked great. Let's take a look at adding coordinates, because I think coordinates are particularly interesting. We don't have that in our schema. Let's add that to our schema, because we get a city. It's got a name and a state, but it also needs some coordinates. I think that looks nice if we make it a separate type called coordinates. And that type will have a latitude and it's of type float. It'll have a longitude, which is also of type float, because that's how latitudes and longitudes work. And so now the city has coordinates, and a coordinate has these types. And we're kind of in the same situation we were before with state, where the coordinate comes back as a string. Like if we run this now and say, go ahead and give me the coordinates of the city as well, including the latitude and the longitude. Let's just make that one line. Right, they're both returning null because it's not finding those properties on a hash. Because actually it's receiving a string and then saying, does the string have the property latitude and longitude? And no, it doesn't. And so we need to do the same thing in our resolvers for coordinates in the city for coordinates as we did for state. And I've got a little helper function I've written to do this, because it's kind of chunky and kind of dense. And so I wrote this little parse coordinates function, and it makes sure that you have a proper coordinate first so that the thing doesn't blow up. And so parse coordinates takes a string which may contain coordinates, or could be null or nil, or some string that isn't any of those things. And so I write a little regex, which validates that it is indeed number, comma, number, which may or may not have a minus sign in front of them, and all these sorts of optional things. But this little regex says this is a pair of numbers separated by a comma that are floats that might be negative, which is what our coordinates are. And then I optionally match if coordinates is defined. If it is defined and it matches, then we just use a simple split and then use destructuring to get the longitude and latitude out. And then once we have the longitude and latitude out, we can return a simple object that contains floats. And then all we have to do for the city's coordinates is override coordinates. And this doesn't need to be async because there's no call to Redis here. And we pass in parent, and we only need parent. We're not looking at the context. We don't need to fetch any data. And we need to say parse coordinates, parent.coordinates. And now when it's time to resolve the value of coordinates, it will invoke this function, which will parse it out and return a hash that the coordinates object can deal with. So let's see if that works. And there are the coordinates of Columbus, Ohio. Now you know where to find me. Cool. So we got one last bit we need to do for our schema here, and that is the places. So we want a haunted place. And we're just going to get those by ID. And that's of type ID, which is required. And it's going to return a place. Let's define our place. And I'm going to copy that from my little cheater code over here. Places have, well, all the fields that are in Redis already. They have an ID, which is of type ID. It's going to be a string when it comes back, or a number. It's got a location, which is a string, and a description, which is a string. These are both for us humans to read. It's got a coordinate, which is a coordinates object, just like we did for city. And it's got a city and state. So let's write the resolver for the place and for the places. And again, this is going to be very, very similar. That stray space there. Call this place. Got parent args context. We only get the ID out of it. And then we call fetch place by ID. Our place is comma there. We'll need to parse the cities and parse the states and parse the coordinates in sort of the same way that we've been doing everything else here. So I'm going to copy this over because this is really just variations on the themes that we've been doing here all along. So if I look at my place, you'll see that this is just the same code that we've been doing here. We'll go ahead and move the coordinates down here so it's in the same order as everything else. Put the comma there. I mistyped a 41 there. It would have been much better if that was a 42. So here we're doing the city, and we're getting the city and state from the parent, just like we did in here, where we're getting the state from the parent. And then we're getting our data source, and we're calling fetch city, which is already written. And then in state, we're doing exactly the same code that we did in city. We're getting the parent, we're getting the data source, we're calling fetch state, and then the coordinates is parsed in exactly the same way that it was for city. And so all we really need to do, save all our files, is add a fetch place method. And fetch place is going to work just like these guys here. So it'll be fetch place, pass in an ID, call this.redis.hgetall place, and pass in the ID. And then we don't need state there. If I stop and start this, this should now return places as well. So let's try it out here. We'll give it a place. And we'll give it an ID of, we'll go ahead and look at the A to which again. And the place has a ID and a location and a description. And it also has a city. And it has a state. And it has coordinates. And this is where I think GraphQL really starts getting kind of cool. Because the city has a name, and the state has a name and an abbreviation. And the coordinates have a latitude and a longitude, right? But the city also has a state. We'll compact this down a little bit here for you, so that I can copy pasta. And it also has coordinates. Copy pasta that as well. And so what's kind of fun here is that the place has a state and the city has a state. They both have states. And so you can get the state two different ways. If you don't care about the city, you can just say, I don't want the city. I only care about the state that this sighting is in, or this haunted place is in. Or you could say, I only care about the city and state. And you could turn some of these on and off and mix and match however you want it. And so it's kind of cool that you can, as a client, your web clients can fetch the data in ways that are meaningful to them. And they can walk that object graph and find the stuff they want. And we can see here that by running it, it did indeed work. The place has an ID of 1, the location is Ada Cemetery. Got a big old story here and a mention of a book called The Ghosts of Grand Rapids. Love a good trip to Beer City every now and then. Shout out to my friends in Grand Rapids. And then here's our city information, which is Ada, Michigan. And then our state information, which is Michigan. And this is our city, latitude and longitude. And this is our haunted places, latitude and longitude. So, cool. We built a super quick GraphQL server using Redis and Apollo GraphQL. That's what I've got for today, though. So thanks a lot for watching. Like, subscribe, and do all the obligatory things for our, our channel here, and hopefully you enjoyed the video. Give it a like if you actually liked it. If you didn't like it, then, let us know in the comments what you think. If you did like it, or got questions or anything, just drop us a comment and let us know what you think.
With me, Guy Royce.
Right in the corner. Ah!